Hello. Now in kinematics of machines, so far we have talked about what are machines, what are mechanisms, what are structures, then what are links, pairs and so on. As well we have understood what is a kinematic chain. Then while designing a kinematic or for the synthesis of a kinematic chain, we have seen one aspect of mobility. That means with the help of the Kutzbach criteria or the Gribler's criteria, we can find out what is the mobility of the given chain we are thinking of. So what is a mobility? Mobility is the number of input motions required to get the desired motion. That means and these inputs what we are talking about, they are the independent input motion. So if I am moving the input link, how the other links or how the motion is getting transmitted to the final output link, or whether it is getting transmitted or not, that is suggested by the mobility of the mechanism. Now, when we were doing so, we were not at all bothered about what was the distance between the two links. Like we have talked about like 4 bar, say for example a 4 bar chain. We have talked about the number of links involved in the chain, the number of joints and their type. We were not bothered about what is the distance between the two joints, or for that matter what are the link lengths. Now this is also one of the considerations. Now when we are designing a machine or a mechanism, now most of the machines or mechanisms, or rather all of the machines or mechanisms, they are driven by the powerhouse, can be or a driver. The driver can be a motor or it can be an engine. Now if you see a motor or an engine, the output of the engine or a motor or the motor shaft or the engine shaft will be a continuous rotating element. So that output shaft will be continuously rotating. That means it becomes important for me to ensure that whatever mechanism I am trying to design, it must have at least one link which can make continuous relative motion. That means it should rotate completely. Then only, like if this is the link which is rotating, that means wherever I am placing on that shaft can be coupled then with the motor. Now that means we need to check, always there has to be a check whether whatever mechanism we are designing, in that mechanism there is existence or there is a link which can completely rotate. Now this link we are calling it as a crank, right? So that means we want to ensure that whatever mechanism we are designing, this must contain a crank. Then only we will be able to couple it with a driver. So there is another aspect, like or there is something called as the Grashof's law. This Grashof's law is helping us in checking whether the mechanism what we have is containing a crank or not. Now what does the Grashof's law suggest? Now this Grashof's law is applicable to 4 bar chains only, right? The reason is the 4 bar chain is the basic chain. All the other extensions of a linkage or a mechanism are extensions of a 4 bar chain. So this Grashof's law, how it is or what it is suggesting. So what does Grashof's law suggesting? The Grashof's law states that, what does it state? It states that for a 4 bar kinematic chain or a linkage, the sum of the length of the shortest and the longest link is less than the sum of the lengths of the remaining two links if there is a continuous relative motion between two links. So what does it suggest? So what does the Grashof's law suggest? The Grashof's law suggests that for a 4-bar kinematic chain or a linkage, the sum of the length of the shortest and the longest link is less than the sum of the length of the remaining two links if there is a continuous relative motion between the two links. I'll come to it with the help of a or in other words also we can express that a 4-bar chain, by chain we mean always a kinematic chain. For a 4-bar chain has at least one rotating link. By rotating link what we mean? That means we are talking about a crank. At least one rotating link if the sum of the length of shortest and the longest link is less than the lengths of remaining two links. So far in the analysis for whatever number synthesis we did, we were not talking about the link lengths, right? But when we come to this situation wherein when we are thinking of driving that mechanisms, that means I need a crank. So when I want to ensure that in my mechanism there has to be a crank, I have to check. So this law is giving me a check whether my mechanism is containing a crank or not. So simply what does it suggest that? So now the lengths of the links are coming into the picture. So in a 4-bar chain, suddenly when we see, so if we see so let us consider a 4-bar chain. So say this is a 4-bar chain, right? So apparently it seems, so maybe this is the shortest link and this is the longest link, right? And these two, so let us name them as P and Q. These two are two other two links. So this is identified as the shortest link. The length of this link is the longest, out of these 4, and these are the remaining 2. So what Grashof's law is suggesting that now, so sum of shortest and the longest link, when this is less than the sum of the lengths, that means P plus Q, if this is the situation in the chain, then this will certainly contain a crank. Or now we are talking about a chain. So when we are talking about a mechanism, what we are doing is we are grounding one link, right? So grounding one link, that means we are selecting one link as the frame. Now here right now we are not specifying which one is the frame. Anyone can be the frame. So if I see this situation, now I can select this link as the frame, or I can select this link as the frame, I can select this link as the frame, or this. So this we have taught in inversion. So that means what it is suggesting now is, if in the given kinematic chain, if this is satisfied, then in that case certainly one link will be a crank. Now that existence can be on all of its inversions or any of its inversions, right? Now if this is not so, if I see that the sum of the shortest and the longest link comes out to be greater than the remaining 2 links, then in this case, then none of the inversions will contain a crank. So in that case, though it is a 4-bar chain, so in that 4-bar chain there will be no crank existing. So in rather any of the inversions. So it will be all giving me rocker mechanisms, right? Now, so as well, there is with the help of these 2 expressions as well, we classify also the mechanisms into the class. Now these such mechanisms, 4-bar chains satisfying this first condition, they are called as class 1 mechanisms. Class 1 mechanisms. And these mechanisms where this condition is existing in the given kinematic chain, 4-bar chain, these are called as the class 2 mechanisms. So simply, now what we can say is, if it is a class 1 mechanism, so in class 1 mechanism, there will be always a crank. So when we say a given mechanism is a class 1 mechanism, that means there is a crank in that mechanism. Now if I say that it is a class 2 mechanism, that means there is no crank existing in that system. Fine. So then as well, now if we see the condition, so if it is such, so let us say there is this right. So let us say this is the shortest link, this is the longest link, and these are the 2 remaining links, right? So now if we see this situation, now there are, so when we are talking about inversions, that means there is a scope of selecting the frame. Fine. Now in this I may categorize these into 3 situations of selecting the frame. Fine. So first, so what we are talking about, selection of frame. Fine. In terms of frame, if I say, so what can be the first case? Now first case is like if the shortest, or rather when the shortest link is adjacent to the frame, right? The first case we are taking as the shortest link to be adjacent to the frame. Now if I see this case, if we say this is the shortest link, so first condition can be what? I can select this link as the frame, or This can be the first case because this one, the frame is adjacent to the shortest link. Or second case can be like so this is the first case where I am selecting this Q as the frame. The second situation can be if I select this link as the frame. So if I select this link as the frame, so this also becomes adjacent to the shortest link. So when we are selecting the frame adjacent to the shortest link, either this one or this one, this will always give me, this situation will always give me a crank rocker mechanism. This will always give me a crank rocker mechanism, right? That means, say in this case, certainly the shortest link will act as the crank. So this is going to rotate completely and this becomes the output link that is going to, so if I am selecting this one as the frame, then it is going to rotate about the frame and I get the output link as P, which will be rocking. Now if I select this as the frame, so the shortest link will be acting as the crank, right? And this will be acting as the rocker output mechanism. Now what can be the second situation? Now second situation is when shortest link is fixed. So when the shortest link is fixed, or shortest link, we are selecting the shortest link as the frame. So when we are selecting, so our second situation, like we are not taking this as the frames. So what we are doing, we are say fixing the shortest link. When we fix the shortest link, this will give me a mechanism called as a drag link mechanism. Drag link mechanism, which is also called as a double crank mechanism, right? So that means you will see that, of course, now when it is the condition is such, whatever the adjacent shorter link will be, that means this as well as adjacent to the frame, these two links will be acting as the crank. So as if this is dragging the other one, and usually the shorter link is considered as the input link, right? And the third situation is when the link opposite to the shortest link is fixed. So when this is fixed, so or that is taken as the frame, in that case we get a double rocker mechanism. So we will get a double rocker mechanism, right? Now in this case you will see that when I am fixing, so in this case when we are fixing, this is the shortest, so opposite to that, when we are fixing the opposite link, we will get like this one and this link adjacent to the fifth frame, they will be rocking, but here in this process you will see that if we go for the configuration, various configurations of the cycle, now here the shortest link will have a continuous shortest link, the shortest link will rotate, or it will have revolution, it will rotate, but these two will be rocking. So this will be giving me, so likewise all the four inversions we will get. Four inversions, what? We will get two crank rocker mechanisms, one drag link or a double crank, two crank rocker mechanisms, one double crank mechanism and one double rocker mechanism. Now in this double rocker mechanism as well, you will see that the shortest link will execute a continuous relative motion, or it will rotate. Now in relation to these, there is another thing which is as well called as the Harding's notations. Harding's notation. Now this Harding's notation is talking also about the same thing, existence of a crank in a system. So if, let us say, if there is this, now in the Grashof's law, when we were fixing, there was no consideration as such which link is, like I have shown you the longest link as adjacent to the shortest. So there is no as such discussion about what should be the arrangement, like which link is after which link. So hardly that is going to make any difference, but that inversions will certainly give me the results what we were talking about. Now here, let us say we name it as if A. Now what is A? Whatever I am alphabet denoting, these are all the lengths, right? Now A is the largest one. Now B is opposite to the largest. B is opposite to the largest. Now this is C and this is D. What is C? C is the link. C is the link which is greater than the remaining two. That means out of D and C, C is largest or longest of remaining two. Right, remaining two links. That means D and C. And last, D is the opposite to C. D is the opposite to the link C. If this is the case, so these are the notations were given by Harding's, hence we are calling this as Harding's notation. So in this case what is happening is that A is the largest link, so we can say here that A is greater than B and C is greater than D. Now what is Harding's notation suggesting? Now as well as if you see here, A plus B is greater than C plus D, right? So now if A minus B is less than C plus D, for this is the first case, so this will always give me class 1 mechanisms. What are class 1 mechanisms? Class 1 mechanisms are mechanisms having crank, and if A minus B is greater than C minus D, then it is giving me class 2 mechanisms. So this is called as what is Harding's notation, right? So so as we have discussed in Grashof's law, that is also suggesting me of the existence or ensuring whether there is a crank in the system or not, as well as Harding's notation is also talking about the same thing, but its notations are given. So in the given chain I can identify which one is the longest one. So to opposite to that I'll take it as B. Then from the remaining two I'll see which one is the greatest. That will become the C, and opposite to C will be D. And when we check for this, we can check for whether the mechanism or the chain is class 1 chain or class 2 chain. Fine. So that is all for this session.